explain the purpose of this lab. So, the good and bad thing about this whole concept of gives free energy and entropy is, again, that we don't have probes to measure any of them. Okay? We don't.
Are you lying?
We got nothing. Okay? So, the reason that I wrote this lab and picked out these 4 reactions is so that you can see how it actually plays out. Okay? Because otherwise it's just like, an academic endeavor. You go, Gibbs free energy is negative. Okay, big whoop. What does that mean? Or entropy is positive. Big whoop. What does that mean? Enthalpy is negative or positive. Whatever. Okay? You crunch the numbers and you get something, bless you. But then you can't visualize it. So this is why I did this, so that you can see 4 particular reactions. And number 1, and again, stay with the spirit of how I wrote this lab. So the first reaction we're going to do this together. Okay? The first one we're going to do together. I'm going to take concentrated hydrochloric acid and sodium bicarbonate, otherwise known as baking soda. Okay? And we're going to mix that together. We're going to do this all together as one group, and we're going to make observations. I'm going to measure temperatures, and we're going to see what happens. Okay? So this is based upon your observations. Okay? There's no math at this point. Just based upon pure observations. You're going to predict, hey, what's the sign of delta G? What's your justification for it? Positive or negative? What's the sign of delta S? Positive or negative? Based upon observation. Then you're going to record the initial temperature, the final temperature, and we're going to calculate the change in temperature for the surroundings.
Oh.
And then you're just going to have the sign of delta H. You're not going to calculate it. You're just going to say, oh, here's my delta H. I think that's going to be positive or negative. Okay? And then you're going to do a reaction with the nitrite and iodine. I gave you this reaction. Okay? And you have potassium nitrite, which is NO2. You're going to react that with some iodide. And notice what you're going to make. You're going to make, if you look at those products, you have I2, elemental iodine. What color is elemental iodine? Brown. You're also going to make nitrogen gas.
Ooh.
So what should you see?
Bubbles.
You should see bubbles. Now, as soon as you see bubbles, what does that indicate about the entropy?
Positive.
It's positive. Okay? But you're also going from having iodide ions floating around to elemental iodine. So you go from free iodides to elemental. So when you go from the ions to the elemental, that entropy is negative, decreasing entropy. So you have 2 conflicting ideas.
Which one's greater, Bert?
I don't know.
Gas.
Yeah,
The gas is always greater.
I agree. Yeah.
Okay.
The grass is always
No.
greater.
On the magnesium hydrochloric acid. Okay? Now, you're going to take a small piece of magnesium ribbon. You all have done this before. Put that in about 5 milliliters of 1 molar hydrochloric acid. Notice I did not say 5.00. This is not a quantitative calculation. You're going to put it in about 5 milliliters. Okay? Put it in a test tube. I don't care. It says 5, not 5.00. Get over it. Okay? I don't want you to sit there with your dry drop and give No, you don't. Okay? In about 5, drop in the magnesium, measure the initial temperature and the final temperature, make observations. Then you're going to come up, I'm going to give you a piece of sodium. I love you all dearly. I'm not going to trust you with a chunk of sodium. Okay?
What about francine?
Huh, no. Well, they don't even let me have that stuff. So you're going to come up. I'm going to give you a small piece of sodium. I'm going to drop that in water, to which you have also added phenolphthalein indicator. Okay? And you're going to measure the initial temperature, and then we're going to drop in the sodium, and then you're going to measure the final temperature. Now, there's one glitchy thing, and it's still going to work. When you get to the reaction with the, where's it at? Oh, with the iodide, that very first page, 4 milliliters of sodium nitrate, and then it says add 5 drops of 3 molar H2SO4. I actually have 1 molar H2SO4. It'll still work. You might have to add some like a couple more drops because it's 1 molar versus 3 molar. And I didn't want to mix up a whole container of 3 molar sulfuric acid for this because 1 molar will work. You just might have to drop in a little bit more. Now, some of these temperature changes will be very dramatic. Some of these temperature changes will be very subtle. Okay? So pay attention to that. Now, when you get over to the calculations part, okay? So, if you look on your equation sheet, there's 2 ways that you can determine, okay, your delta G. One,
Bird we can't see.
I can't see.
it was weird, first block, this thing wouldn't even turn on.
Are they a good luck?
Where am I on time?
Hey, testing. Yeah.
Show them the pictures.
Hey, look at testing.
You have 6, 7 water?
Yeah, the 6 up. Can you
I've got 1 6, 7 water.
Oh, really?
It costs like $20 for 6.
Yeah, that guy's committed to KU now.
Yeah, yeah.
What's his name? Tyler Doe.
Yeah.
Okay, so there's 2 ways that you can calculate delta G. One is you can use delta H minus T delta S. That's one way. The other way that you can do it is the same process that we use for enthalpy of formations, where you looked up and you added up the sum of all of the products of your enthalpies and subtracted the products, and then went through that whole process. You can do the same thing with delta G. So when you get to C, like on page 2, this is the reaction between hydrochloric acid and sodium hydrogen carbonate, otherwise known as baking soda. So you're going to look up the sum of the enthalpies, and you've got to go to the back of the book, and you've got products and you have reactants. Then you're going to do the same thing for delta S. So then you're going to do the same thing for your delta G. So that index in the back of the book is going to become your friend. The math isn't complicated. Where things go wrong is usually people write down the wrong numbers. So because you have pages and columns of all of this stuff, I highly recommend that you might even take like a piece of paper and like use that across so that you know you're getting that from that particular information. Shannon Jones.
Are we basing the stuff on page 2 off of standard conditions, or
Yes.
the stuff we use standard?
Standard
So
conditions.
like not the mold that we use in this.
Yeah, you're going to base it on standard conditions. Now, here's when you get to F on page 1. So, using the equation delta G equals delta H minus T delta S, you're assuming standard conditions, determine delta G using these values. So there's 2 ways that I want you to calculate delta G. One from the sum of the products minus the reactants, and the other one using delta H minus T delta S. But you've got to use the delta H that you found up above. You have to use the delta S up above, and then that temperature. Okay, so the observations don't take very long. The math takes a while. So bring me on your camera if you would.
This is a 2-day lab or one?
All right.
Yeah, this is that.